Welcome to this quick and practical guide on data preprocessing with Python for data science. In this video, we will walk through the essential steps of preparing your data before analysis or modeling. Whether you're just starting out or refreshing your skills, this is the foundation every data scientist needs. We will begin by importing the right libraries and reading your dataset. Then we will explore how to understand your data, manage data types, rename and drop columns, and subset your data frame efficiently. From handling duplicates, filtering rows, performing operations on columns, to dealing with missing values, we've got it all covered. We'll also learn how to group, merge, and reshape your data, and finally, how to export your clean dataset. Let's dive in and get your data ready for analysis. For the dataset, we will use the SHIP performance clustering dataset, which you can find on Kaggle. You can see the link here. And I've also prepared a GitHub link in the description box below, where you'll find the dataset in its CSV file and the Jupyter Notebook file that we are going to program today. Okay, then let's start with the first chapter, the libraries. In this tutorial, we only need one library, it's Pandas, and we're importing it with import pandas as pd. And we'll start running the cell. As you can see, we've loaded it. And what is Pandas? Pandas is the backbone of the data manipulation in Python. It allows us to load, explore, clean, and transform dataset. Throughout this tutorial, we will use pd as the alias for Pandas, which is a common convention in the data science community. So when we are calling a command from Pandas, we will always put the pd before. In the next chapter, reading data, we will load our dataset into Pandas data frame. And reading data is the first step in any data project. And what we're going to do is we're loading a CSV file. And once we've loaded the data frame becomes our working environment where we can explore and transform the data efficiently. And for that, we are setting our path file. And in our case, it's only the relative path to the dataset. It's called SHIP performance dataset.csv. And I will show you in the file. Here we have our Jupyter Notebook, and here's our dataset. And since it is relative, our dataset is relative to the Jupyter Notebook, we just need to, the file path is just only the file name. Then we are loading the dataset. I call it the data frame war as pd.read CSV. And then we are giving the file path, and then the separator of comma. And when we are loading it, and we have seen it is run, it's completely working. Then in the next file, I will make a copy of the raw dataset, so we can work with only with the data frame as def. And if we're needing the original raw file, we can always go back to def raw. Let me add some comments to the code. So we are defining the file path to the dataset. We will read the data from CSV with comma as separator or delimiter. Then we will make a copy of df raw, and this is because usually when we do some operations on the data frame, and if we are subsetting a data frame, do our manipulations, usually the transformations and changes we also make on the original file, and so that we always have like one original file without any transformations, we will use a copy to have an alternative file. Since some operations will change your data frame. Okay, that's it for loading the dataset. Now we can go to data understanding. So what does this mean? We will get a bit familiar with our dataset. So we will explore simple but powerful commands to quickly inspect the structure of our dataset. We will look at the first few rows, take random samples, check the number of records, view specific columns, and peek at the end of the dataset. And this quick checks help us to understand what kind of data we're working with and spot any immediate issues. So first we review the data, and for that we are taking our data frame. It's stored as df, then dot head, and we give a parameter 5. This will mean that we are looking at the first 5 rows of a data set. And as you can see here, we will see now the first 5 rows. We're starting by index 0 and go to 4. And then you see here all of the data set, of shipment data set, all the columns, and data set, and this first 5 rows of the data set. Yeah. And since it's the first 5 rows of data set, we can also look at the sample of a data set. Like if we want to sample 5 rows of our data set, and for that we can take the df dot sample. When we give number 5, of course we want 5 samples out of it. When we give a random state equals this any number here, and this is like the seed. And then we get like 5 random samples from the data set. You can see this on the index. It's all like some random numbers. And now what we also can do is we can look at the last 5 rows of a data set. And for that we're using df.tail and 5. Okay, I've made a mistake here. It's called tail. And then we can see we have the last 5 rows of a data set, and we can also see here what we have for index 2735. So we start with index 0, so this means technically we have 2036 rows, but we'll go later on that. Okay, now to check how many columns and rows we have, we can use the command df.shape. And then you can see here we have 2736 rows and 18 columns. And to check for the length of the data set, we can use length command. Length, when we use input, we give our data frame, and we get 2736. So it's like the number of rows. This will become handy with command length df if you maybe want to iterate over the rows, or only get to a number of rows to have some normalization transformations. Okay, now say we want like to access here a column of a data frame. For example, we want to look at the ship types. And what we can do is we take the data frame, accessing a column of df. We take our data frame, then in brackets, you just type the name of a column, ship type, and pressing enter. We get here a series with all the data. We have like the first row was container ship and fish carrier container ship. We compare it here with this one here. Index 0 is container ship and fish carrier container ship, etc. So we're getting the data from the column. And what we can also do is we can also access the first 5 rows of a specific column. So first 5 rows of ship type column. And for that we are taking the data frame, brackets, name of a column, ship type, then dot head 5. And I'm running it, and you can see here, get the first 5 rows. And if what we here see is like more pandas Python series, but if you want also like a data frame, like we've seen here, you can also just use the command ship type columns as data frame, where we put in the data frame, then first bracket. So we take data frame, first bracket, then inside the brackets again brackets, and then we give our column name, ship type, and this says to pandas what we want from the column ship type, a data frame, and then we get this result this. And of course we could also put in some more names. For example, we also put a second name would be, for example, root type. Good here, root type, and we get like 2 columns, like subsetting a data frame. But we have a separate chapter for that where we use those kind of things. Okay, now we can go to the next chapter to understand the data types. It's crucial for working with our data set correctly. And in this section, we will use like commands to check the current data types of our columns. When we will learn how to convert them using as type. For example, changing strings to numbers or numbers to categories. And we will also take a quick look at special data types like categorical and datetime, which can improve performance and make certain operations easier. And cleaning and adjusting data types ensures your analysis runs smoothly and accurately. And that's also important since some of the data transformations depends on the type of the data. Okay, and so to get an overview of the data types, of our data frame, we just use our name of the data frame, df.info, and then we will get a list of our columns, and we see here on the right the numbers is the number of column we have, the name of our column, and then how many null count, so how many values we have where we get a real value and not a none. And then in the last column here we see what data type we have. We can see it's like an object, float, object, int. And so we have to make some changes on the data set so that the data gets like proper data types. For example, if you look at ship type, it's like an object data type, but in the end it's more like a nominal categorical data type since we have like a few categories like container ship, fish carrier, etc. And we want that they are considered as categories and not as object. So we can do some basic statistics on that. Yeah? Okay, so now we want to change some data types. Changing data types. For example, we know that ship type is an object, but I would like that to be a category. So what I would do is I name the data frame, brackets, ship type, column name. So to get the column, then equal. I want to revalue the data type. So equal data frame, and again ship type dot as type. So we want to give now our new data type and now category. And then I will look at df.info to look at the result if we have made the change. And as you can see here now, in the first column ship type, our data type is now category. Okay, so this is done. And now you could do it for practice on the other data types, like root type should be category, engine type, maintain status, weather condition should be also category, and the rest is okay. And now to date should be not it should be a date type. And now what we're going to do is we're making the date to date type. So we go df date equals df brackets date, calling the column and as type, and we have to put in the name of a category, and it's called date time 64 nanoseconds. Yeah, this is like how we would convert a date object to a date time data type. Now let's look if a change is made, and now we can see first column date is now a date time. And this is now an important thing for dates to do that, because date time data type gives us some more features that we can operate when with them, like adding, for example, with like a date type like a month, you can also add then hours to it, seconds, weeks, make some calculations on it, and for pandas, Python will automatically make the calculations. But we will do this maybe in a separate video to time series analysis, since that's very important. Okay, now we can go to the next chapter. So here we will focus on working with columns, one of the most common tasks in data preprocessing. We will start by viewing all column names. Then we learn how to select the columns using the names or index positions, something what we already did. And then we look at how to drop columns we don't need, helping us clean and simplify the dataset. Okay, so to get the column names, just call our data frame dot columns, and we get here the list of all column names. Okay, and if you, for example, would like to iterate through the column names, we just use a for loop for col and df.columns. Then we will, for example, print the name, print the column name. Then we get here a list, for example, if we like to do that. This can maybe be important. We would like to make some specific transformations, and they're all the same if there's some specific columns, and then we could make it all in a for loop. Okay, now for renaming a column, we just say, okay, we take our data frame and we revalue the data frame with a new rename. So take df rename and then columns, and then now we give a list of which old column names we want to change to with new column names. And for example, we could go to ship type as our old column name, and the new column name should be like new ship type. Yeah, and for example, for a second example, we could take the root type and changing it to the new name, new root type. Okay, and if we're looking at the first rows, we will see here that we get now a new column name, new ship type and new root type. Okay, that's for renaming the columns, and this can be also important since a lot of data sets come with some improper column names where we don't have like the underscores or some spaces between names. For example, we could have something like new ship type as a column name with 4 spaces between, but we like to have some underscores since this is better for data handling. And then we need to rename the column names, or the names are maybe too long and we would like to shorten the name. Okay, and how do we drop a column? Maybe there are some columns that we don't need at all. So what we're going to do is we call our data frame and then drop. So we have dropped the column, and now if we want to look like in the whole data set, we can use df.info, and then we can see that there's no column with the name date. So it's completely gone, and we have only 17 columns before we had 18. Okay, now let's have a look at subsetting a data frame, and that is how to select specific rows and columns to focus on the data that matters. Whether we are filtering by condition, selecting slices, or combining both, subsetting is at the end a very powerful way to zoom in on the parts of our data set which are most relevant to analysis. And first, what we can do in very fast way is to go into the columns, take the column names, just take the column names, copy it. Then we are saying, okay, we are subsetting the data frame. Let's call it a new data frame subset equal df double brackets because we want a column name. So let me delete one brackets here. Yeah, so we have here df double brackets open, and we're closing with double brackets. So this means we are having a data frame, and now we have like all the columns from our data frame df. And now we can just comment out the column names which we don't want. This is a very fast way to subset a data frame. For example, we only look at the ship type, root type, engine type, and I also want to look at the weather condition. I can delete the other column names. I can delete this. This can be deleted. And the rest can also be deleted. And then we have like a subset of data frame. And so we have a data frame subset equals data frame, and we take only those column names that we want to look at. Now, and of course we are taking a copy of this data frame, since we don't want, if we're making changes on the subset, we don't want that those changes are made when at the end as so in the df. So this is very important to put the copy inside. Now we can look at dataset set head 5. Then we get here our new data frame with only 4 columns. And we can also look at df subset info. And we can see here all the information we have. Okay. Now what we can also do is we can filter the data set by rows and filtering data sets by rows. And we can use the command log for that. For example, take the df data frame dot log, and then we give in the brackets, call our data frame. For example, then the new ship type. And for example, we only want the rows of our data frame where the new ship type is equal to a bulk carrier. And then we get only the rows of our data frame where the new ship type is equal to bulk carrier. Yeah, so this is kind of way of querying a data frame. And we could also use different kinds of operations. For example, we could take, let's say, we take the ship over ground nodes. Since this is like a number, a float, we can say it should be bigger equal than 21. And then we get all rows where the sheep over ground nodes are bigger than 21. If you look here. So one other way we can do, and we can also combine queries. For example, we could say we take the ship over ground nodes and the maintain status with good. So we take df maintain status equals good. Yeah. And I would also like here some curly brackets on the first statement. Okay. And then we can look dataset. We have only the rows where its maintain status is good and speed over ground nodes is over 21. Now this kind of making some search in the dataset. It's very fast and efficient, and this is very important for subsetting a data frame, since a lot of time we are very interested in very specific values of a dataset. That's how we can get those rows to do later some statistics on it. A very interesting operation is, for example, if we want the opposite of this condition. For example, if we want all the rows where the speed over ground nodes is bigger equal 21, but it should be not good, so it should be the opposite of good, so we want all the other data, when we use a tilde before that, and then we get all the data, all the rows, the maintenance status can be fair, critical, or any other besides good, and still the speed over ground is over 21. This is very handy in if you want to isolate one condition. And of course, if you would like to save this to a new data frame, since you want to make some operations with it, you can say, for example, new data frame equals our query, and then always like taking a copy of it. And then we can look at df new dot head 5. So we can see here still applied, but in a new data frame. Okay, now we go into the next chapter of duplicate rows. And duplicate rows can distort your analysis, so it's important to identify and handle them. And that's how we're going to do it. We take our data frame. When we look at all rows where the data frame has duplicates, and with this command we will get all rows where we have duplicates. Getting duplicates. And what we get here as a result, only the column names without any data rows. This means we don't have any duplicates in our data frame, and this is a good thing. And if we had duplicate rows, how do we delete them? Delete duplicate rows. It's very easy. We take like we take a new data frame, for example df new or df no duplicates equals, when we're taking, for example, here the command we want all rows, take a copy, and then since we don't want duplicates, we only press a tilde before it, and this means not duplicate rows. And then what we can do is, since if we're deleting the duplicate rows from our data frame, the index will not be, this index here, those numbers will not be changed, but we want to reset them. Reset index drop equals true, and this means if we're dropping some rows, the index is going to be reset. And this is what we're going then to do. Since now we don't have any duplicate rows, nothing's happening here, we just copied our data frame. Now we want to query our data frame. Technically, we already have queried our data frame already with command log for location. There's also a different way of querying a data frame with a command .query, but usually we only use, I would say, this command of log. But nevertheless, I will go in with query command, query data frame. And for example, if you want to query the data frame for the ship type, where we have like bulk carrier, like we did before. Now we want to query our data frame, say df.query brackets, then quotation marks. Then we want, for example, give the first query, type in type ship. Okay, so we take the new type ship, and we're saying, okay, we should be equal at ship type. This at is important, since in the query we have like in the quotation marks, we can say to the query statement that at ship type is like a variable that we have defined before, and this is like the bulk carrier. So this will automatically insert when bulk carrier here. And if you want to put in a second query, we have like a condition, we have like new, should be called new root type, and here new ship type, sorry for that. And this should be equal to transoceanic, where we take the head, and then we get like a query data frame. And this is like the results are the same like using log, but I would recommend using only log. And maybe if you come to a point where log doesn't really work, then maybe use query, but I've never experienced like that. I think maybe there's only a difference in speed or efficiency. Yeah. Okay, just for that you know that there's also a second method for querying data frame with query. Now let's do some basic statistics. So we want only to perform some basic statistical operations on our columns, like calculating the mean, median, minimum, maximum, etc. And these are like quick summaries to give some first insight in our data. And it's technically very simple to get the summary of the numerical values. We just take our data frame and run the command describe. Then we get like all the statistics, like the count, mean, standard deviation, minimum, then some quartiles, to a 25% quartile, 50% quartile, 75% quartile for max. And we only get this to the numerical values, to the columns with numerical values. And yeah, so it's technically, if you want to have only the statistics for some specific column, we would usually subset the data frame. For example, we only want the ship type, and this is like a category. For example, new root type dot describe. Then we get only those statistics that's applicable to categorical variables, like count, how many unique levels we have, what is the level with the most frequency, this means top, and frequency is like how often this occurs in the data set. And what's happening when we are mixing data type, like new ship type is categorical. Let's take some numerical values. like speed over ground knots. I will paste it in, and now something weird happens. What's happening is that the categorical variable is completely ignored. We only see the data of speed over ground knots. And that's because describe is by default works only on numerical values. So if we want to use it on categorical variables, we have to subset it first only on the categorical variables. Okay, so that's very important. But we can also do, if we don't want a summary of the statistics, do some specific statistic directly on the column. For example, we can take the data frame, run the speed over ground. And we can say, for example, dot mean, and we get the mean value. So there's some specific commands where we get those values, and this is important if you want to make some specific operations, transformations. We only need one value, then we can get it with those commands. And here I've pasted in some of the basic commands which are available and which are used very often. Of course, we can also min and also take for the max. Okay, yeah. And if you want to calculate some more statistics, like in a table we have done here, we can use the aggregate function. So in this case, for example, if we take the speed over ground knots and the engine power kilowatt, we want to aggregate the values mean, max, and standard deviation, where we get like a custom table, custom data frame, where those values are calculated. That's also very effective. So for command aggregate. Now, for example, for categorical variables, if we want to know like the unique levels, we can just use the command unique. And then we get all the levels. We have like container ships, fish carrier, bulk carrier, none. So we have some values where it's not specified, tanker, etc. And if you put before the unique the letter n, then we get the number of unique values. It's 4. And remember, none values are not count. So it's only 4 different kind of levels, and with none would be like 5, but they're not count. And then we have like the command value count, which means we get the frequency of each level. So bulk carrier we have a frequency of 669, etc. And if we're using the command normalize equals true, then we get the relative frequency, so the percentages. So we can see it's quite equally distributed, like every level has around 25%. Now we come into the chapter of missing data handling. And this is like very common, as we have seen, that we have some columns where some values are not specified, so with the value none, so where data is missing there. And this can be very distorting, like a statistic. So what we want to do is usually delete those rows, or we want to impute some data for those. Okay, and the first thing what we can do is to look in a specific column, like how many nuns we have, how many none in a specific columns. We can just look at by current data frame. When give columns as data frame, so for example, new ship type, and then we add the command is NA. This says, okay, if it's NA, when we get the value true, and when we are summing up those true values, and then we get as a result that new ship type has 136 NA values, none values. So 136 values are not defined. Okay, and if we would like to drop the rows, dropping rows with non-values, then we would take the data frame, say drop NA, and subsetting, for example, new ship type. And this command we get the data frame where we don't have any NA non-values in the column new ship type. And what's also happening is if we want to replace non-values, for example, we define